fourth grade Cougars, it's Mrs. Belatesh. I want to do a quick little review about what we did last week. So energy makes things happen. Energy has a source. Most energy on Earth comes from the sun, but the sun's energy is stored in plants, it's stored in food. We take the energy from the sun, we make chemicals, and we store it in batteries. We store it in the candle of the wax of the candle. So there's a lot of ways that we can store energy, but most energy on Earth comes from the sun. Last week, we talked about two types of energy. Potential energy, the energy of position. If we take a ball and we raise it high in the air, it has more energy than a ball that's low on the ground. And we saw that with the ramp, right? When we had a ball low on the ramp, it had less potential energy and the ball moved slower. When we had a ball higher on the ramp, it had more potential energy and the ball moved faster. And then we talked about kinetic energy. Kinetic energy is the energy of motion. When the balls were moving, they had kinetic energy. When I'm talking, when I'm doing all of this stuff here, I have kinetic energy. So now we're going to start talking about the energy that is transferred using waves. Waves. Well, we think about waves at the beach, right? The waves come in, and if you're a surfer, you like to ride the wave. But another type of wave that we talk about a lot is a sound wave. And I have my little bowl, and I have a rubber band on it, and I can pluck the rubber band and it makes sound. And you can see that the rubber band is moving back and forth very quickly. It is vibrating. So how does the motion of this rubber band moving back and forth make sound in our ears? How do we observe it, and how does it get from here to here? So here's my cup. My rubber band is vibrating. And what's happening is that when I pluck the rubber band, it moves back and forth. And it pushes on the air that's all around us. I know that it's hard to believe that this little rubber band is pushing on the air and making sound, but that's exactly what it's doing. It pushes on the air around the rubber band, and then that air molecule pushes into the next one, which pushes into the next one, which pushes into the next one, which gets finally to our ear. Our eardrum then receives that pushed air molecule and that sound wave, and we hear. Here is a little basin of water, and there's a ball floating on top, and I'm going to give the water a little push. Do you see the waves in the water going up and down? Do you see how it's carrying the ball? It's making it move up and down. The ball is not moved by the water to a new location. It just bobs up and down on the wave. The water carries the energy through the water, but the water does not really move to a new location. So I have a rope, and it's tied to a stool in my science lab, and I'm going to give the rope a little push and pull. And the energy in my hand is transferred to the stool. And the thing that transfers the energy to the stool is the rope. And the rope moves in a wave pattern. You can see the wave pattern really nicely when it's on the ground. The wave has names for the different parts of the wave. The highest part of the wave is called the peak. The lowest part of the wave is called the trough. And the length between two peaks is called the wave length. A wave is a repeated pattern of motion, up and down or back and forth. And waves carry energy from one place to another. These waves, you can see the peak and the trough. You can see the wavelength, and it's carrying the energy from my hand over to the stool. The wave travels through the string, through the rope, but it doesn't carry the rope to a new location. The rope just carries the wave. Okay, fourth grade students, so I want to talk about a wave in a slinky. So Miss Ava is going to reach forward. She's going to pull back the slinky, and then she's going to let go. Ooh, watch the slinky move back and forth. Didn't we say that a back and forth motion is called a wave? And now Miss Sherry is going to reach forward. She's going to pull back on the slinky and let go. And there goes the wave traveling through the slinky. Notice that the slinky didn't go from her hand to Miss Ava's hand. The slinky is still in the same location, but the energy is carried to a new place. Ava's going to do it again. She has the energy in her muscle. She lets go of the slinky, and the energy travels over to Miss Sherry. She can feel the energy arriving to her through the slinky. Now Miss Sherry goes it again. She pulls back on the slinky. The energy in her muscle is going to go travel through the slinky to Miss Ava. And you can see the motion going back and forth through the slinky. Let's review the parts of the wave. The highest part of the wave is the peak. The lowest part of the wave is the trough. And the distance between waves is the wave length. And you can measure the wavelength from peak to peak or from trough to trough. Amplitude is a description of how high or low the wave is from the center point. The waves on top have a very high amplitude. The waves on the bottom have a very low amplitude. Frequency tells us how much energy a wave contains. Frequency is how many waves pass a single point in the same amount of time. The wave on top has many more waves passing the blue line in the same amount of time that the waves at the bottom will pass. The wave on the bottom has a lower frequency and has less energy. The wave pattern on the top has a higher frequency and more energy. Today, we learned a lot about energy, and specifically energy that is carried by waves. Sound waves, light is a type of wave, all kinds of waves that are traveling through the air, and water all the time. When we look at a wave, there is a wavelength. The wavelength is from peak to peak or from trough to trough. It is the distance between those two parts. The peak is the highest part of a wave. It could also be called the crest. If you go surfing, you ride the crest of the wave, or the peak. The bottom of the wave is called the trough. Sometimes it's called the valley, but it is also called the trough of the wave. energy that travels through waves, the wave carries the energy. It doesn't carry or move the material. It doesn't move the rope from one place to another, but the energy travels through the rope. The energy travels through the water. The energy travels through the air. That's why there's no sound in space. There's no matter. There's no air in space. So you can scream as loud as you want, but there's nothing there to carry the energy from your voice out. So there's no sound in space. Next week, we're going to do something with light. See you next week, guys.